My name is Sai Sanjana Mummaneni. Today I'm going to give a presentation on Pike OS, which is a real-time operating system. In today's topic, I'm going to discuss about these contents, which is the introduction of Pike OS, what is a Pike OS, and its historical perspective, its standards and platforms, the features of Pike OS, and the certification kits which we are going to use in Pike OS, and the new versions of Pike OS, that is 5.1, and the Pike OS for MPU, and supported guest OS types, and the IDE Codio, which we are going to use for the Pike OS, and advantages and disadvantages and future trends of the Pike OS. The Pike OS is a commercial hard real-time operating system which features a separation kernel-based hypervisor. This hypervisor supports multiple logical partition types for various operating systems and applications, each referred to as guest OS. Pike OS application is designed to facilitate the development of certifiable smart devices for the Internet of Things by adhering the standards of quality, safety, security across different industries. These are the historical perspectives of the Pike OS. The Pike OS was emerged in the early 2000s as a response to the increasing demand for robust and versatile operating systems in safety critical and embedded systems. It was developed by Cisco AZ, a German company specializing in embedded solutions. The Pike OS was envisioned as a cutting edge real time operating system and hypervisor. Its journey began with a focus on addressing the unique challenges faced by the industries such as aerospace, automotive, railway, industrial automation, and medical devices. The Pike OS aimed to provide a platform that could meet stringent safety and security standards while offering flexibility and scalability for diverse embedded applications. These are the standards and platforms that we are going to use for the Pike OS, and the DOC 178C. This is the standard essential in avionics that ensures the airworthiness of software in airborne systems. The ISO 26262, it focuses on automotive safety. This standard addresses the functional safety of electrical and electronic systems within vehicles. The IEC 61508, it's applied across industries. This standard provides guidelines for ensuring the safety of electronic systems. EN 50128, this platform is especially for the railway applications. This standard ensures software safety and reliability in railway control and protection systems. Coming to the platforms, the Pike OS supports a range of hardware architectures, providing flexibility and compatibility. Compatible with both 32-bit and 64-bit x86 based hardware platforms, and ARM architecture is designed to run on ARM based hardware. Power architecture supports hardware platforms prevalent in industries and automotive applications. And Spark architecture, it has a hardware platforms often utilized in aerospace and defense. And these standards and platforms govern Pike OS design, development, and deployment, ensuring its sustainability and reliability across diverse safety critical and embedded applications. So Pike OS, RTOS, and hypervisor, and this is the architecture of the Pike OS, and it has a real-time performance, application separation, hardware consolidation, use of cards. It has a certification kits, and it is an IGAR free. The real-time performance, the Pike OS provides predictable and consistent real-time performance, making it perfect for critical applications. The Pike OS uses stringent partitioning and strong separation to provide built-in security by design. And extreme flexibility allows for independence from vendors in selection of hardware architectures. Using commercial off-the-shelf cards, components reduce overall application cost. The Cisco provides the appropriate certification package to assist customers in dealing with the certification authorities. As a European company, the products have no export limitations and thus ITAR free. These are the features of Pike OS. The safety certification. Pike OS has been designed from ground up to be certified according to major safety standards for industries like avionics, space, railway, automotive, or industrial automation. There exist a number of internally accepted standards for the certification of safety critical software. As different as these standards may seem, they do share some common principles. The needed effort to obtain certification for a given program is generally high and it depends on two parameters, that is, a code complexity and criticality level. The effort of certifying a program is roughly proportional to the amount of code to be examined, and this comprises the code of the program itself but also that of the runtime environment. The safety standards assign levels of criticality of applications according to the worst potential damage that could result from a malfunction. Although they use different nomenclatures, the general concept in all of the standard similarities, the higher the level, the more rigorous testing or even formal verification needs to be done. A security universal requirement, the Pike OS with its separate kernel approach is the top choice for systems requiring protection against cybersecurity attacks and is widely used in IoT, edge systems, and critical communication infrastructures. And the virtualization and real time, the Pike OS uniquely combines the virtualization and real time technologies, enabling the consolidation of complex embedded circuit boards onto a single hardware platform, including support for few new concepts like big system on chip with multiple processor cores. Several hardware architectures, the Pike OS supports processors that come with a memory management unit, MMU, as well as less complex SoCs, that is a system on chips, and that contain a memory protection unit, that is MPU only. Certification kits. The safety certification, the Cisco experienced senior engineers accompany that project during the entire life cycle from the early steps to the final deployment and beyond. Sorry. Coming to the avionics and defense, the software certification in avionics is DEVO 178C. In civil avionics, software related to functional safety is certified according to DEVO 178C. Here we find the most stringent assurance objective for the software safety, the most pioneering methods for their implementation, and most advanced approach to control the costs. Aerospace manufacturers use more and more COTS, that is the commercial off-the-shelf hardware and software components, for the avionics control systems in the integrated modular avionics. Next, the ECSS, which is a software certification in space. The software certification in space offers standards for the space software engineering encompassing all phases of development within a space project. EN 50128 and EN 50657, it is a software certification in railway. The railway increasingly depends on a software application with safety critical functions. They have to be certified according to EN 50128 with internal acknowledgement. Due to transnational cooperation, a modular software platform can help to reduce certification cost and speed up the process. The ISO 26262 and it is used for the software certification in automotive. The automotive industry is software driven. Today's vehicles, which are equipped with up to 100 ECUs, which often have safety critical functions. And the standard regulates the use of software in safety critical environments in automotive applications. The IEC 61508, it's a functional safety certification for programmable electronic devices. In the industrial automation and process control industry, the risk management and safety aspects become increasingly important for the selection of software platform in embedded systems. The certification of software component according to IEC 61508 is a part of the project. And the IEC 62304 is software in medical and health, where the sophisticated medical devices have to be certified according to IEC 62304 and the standard for functional safety in the medical industry. These appliances are more and more used directly for the patients to prove a safe and sufficient operation as software open as integral part of medical devices technology. So these are the safety levels for each of the markets. The where the avionics has the safety levels from DAL-A to D, which has but the assured Cisco level was DAL-A, and the space has the safety levels from the category A to D, but the assured Cisco level is category A. The railway has the safety levels from SIL 1 to 4, but we choose SIL 4 for the assured Cisco level. And the in automotive, we have safety levels from ASIL A to ASIL D, but we choose ASIL D, which is the highest, and this is the secured Cisco level. And the industrial automation, we have the safety levels from SIL 1 to SIL 3. And we have SL14 only for the hardware, so we choose SL3, which is a pure software. Coming to the security certification, in a security critical project, the component systems engineering is a prerequisite for success. If your goal is certification according to common criteria or an admission process in the context of military project, the Cisco can do more for you than just hand you over our security target. The common thing is the common criteria. The Cisco Pike OS Security Certification Kit helps customers prepare their certification in projects that are aiming for a common criteria evaluation assurance level, from the Federal Office of Information Security or the Airbus up to the highest levels. The common criteria addresses protection of assets from unauthorized disclosure, modification, or loss of use. What's new with the Pike OS? The Pike OS 5.1 is the new version which is available since 2021. These are the major improvements and changes that has done in this version, and those are L2 cache partitioning available for selected PPC process, priority inheritance mutexes, and IO stream functions for the Pike OS C environment. Pike OS native APIs, that is C++, for 2014 support, and Pike OS native API supports the lightweight API stack. And these are the new features that we got for the Pike OS 5.1, that is the partitioning shared cache of E6500 PowerPC process. It improves the deterministic behavior in terms of worst case execution time, and it assured proper functioning of embedded systems. The enable priority inheritance for mutexes in the Pike OS thread API, it mitigates the problems caused by the priority inversion in complex systems. And the priority inheritance contributes to desired system behavior. The Pike OS native API, it extended with the additional C++ library functions. It builds applications more comfortably to port existing C++ code to Pike OS. The C++ is now available as well as a key parts of the stream-based input-output library functions. And the utilization of file handling operations, opening the gates for the file-based data processing without being bound to each API or guest OS. The low memory footprint TCP or IP stack lightweight IP, this is the option for the intelligent edge device running Pike OS native to communicate with the cloud. And the Pike OS for MPU, this is the architecture for the Pike OS for MPU. And thus, the Pike OS for MPU is aiming to provide a safe and secure execution environment for medium-sized hardware. platforms which do not provide a memory management unit and therefore cannot be run the standard Pike OS. So, and these are the new features that we got with the Pike OS for MPU 1.1. Uh, so the integration with Coreo 7.4. These are the major changes that we got with the MPU 1.1. The corresponding new licensing server and Pike OS for MPU 1.1 is now only supported by Coreo 7.4. And we're going to use the memory map tool, the Coreo web page for the improvements and the other features. So these are the new features for the MPU 1.1, that is the improvements, availability, and the last one is the Dahliang, Dahliang NG Ultra PSP specific changes. Coming to the improvements, the major improvements are they removed the MMU related entries and updated GCC and utilizing the low latency scratchpad memory. And coming to the availability, the MPU 1.1 is available since June 2023. These are the supported guest OS types that we have. On top of Pike OS, we have different partitions which can host entire operating systems, allowing each partition to operate independently from the others. And with mixed criticality, the Pike OS supports various guest OS, runtime environments, and application programming interface such as Linux, Android, Illinois OS, Windows, POSIX, ARA, Ring, Pike OS native, and many more. Today I'm gonna discuss a few OS types, that is Lin OS embedded Linux, which is and Windows, POSIX, Ring 653, and the Pike OS native. The embedded Linux is a distribution offers that most straightforward integration into the Pike OS virtual machine, as well as dedicated extensions to directly use enhanced Pike OS features. The Linux operating system partitions are often used alongside a POSIX or ARINC 553 partition. The Pike OS hypervisor technology ensures that running Linux has no impact on the certification aspects. Supporting the Intel hardware virtualization, PikeOS can seamlessly run an unmodified and fully functional Windows together with other guest operating systems on one single platform. So, for older systems, our solution can safeguard legacy assets while enabling interaction with more modern, secure Windows environments for the communication purposes. The POSIX API, which is a portable operating system interface, implements a subset of the PSE52, the real-time controller system profile. It is good choice for the medium safety critical systems, but a huge number of operating system services are required. But the use of Linux would still be too risky. It is often used for automotive projects, and the compliance is necessary. The POSIX API is a backbone adaptive solution. And the Pike OS RINC 653 is built upon the Pike OS native API and provides complete and fully functional Apex API target for the avionics systems. The Pike OS native is primarily designed to build para-virtualized guest operating systems. It provides small but complete set of low-level system calls that are optimized for the performance, robustness, safety, and security. The Pike OS native API is also the first choice which it comes to the software to be certified at the highest certification levels. The platform for the Pike OS, that is IDE Coreo, the Eclipse-based IDE Coreo, supports the system architects with graphical configuration tools, providing all components the software engineers will need to develop. The embedded applications, as well as including comprehensive wizards to help embedded project development in a time-saving and cost-efficient way. And these are the features that the platform should providing: the guide configuration, the remote debugging down to the hardware instruction level, the target monitoring, the remote application software deployment, and the timing analysis. So these are the advantages and disadvantages of using the Pike OS RTOS. It is safety and security compliance. The Pike OS is engineered with strong focus on meeting rigorous safety and security standards, making it a viable choice for the industries like aerospace, automotive, and medical devices. And Pike OS offers robust partitioning and isolation features, allowing multiple operating systems and applications to coexist on the same hardware platform without compromising system integrity. PikeOS boosts the real-time capabilities essential for the application with strict timing requirements such as automotive control systems and industrial automation. The PikeOS supports a wide range of hardware architectures, providing versatility and flexibility in system design and deployment. With the separation of kernel-based hypervisor, the PikeOS facilitates hardware virtualization, allowing for the consolidation of multiple applications onto a single platform. Coming to the disadvantages, the complexity implementation deploying PikeOS in a system demands expertise in embedded systems development and safety-critical software design. The virtualization and partitioning overhead in PyQuest may lead to increased resource utilization, including memory and processing power. Coming to the cost considerations, PikeOS is a commercial product and licensing fees for the development and deployment may be incurred. So, moreover, the certification process for safety critical applications can be both time consuming and costly, adding to the overall expense. The learning curve transitioning to PyQuest may involve the necessitating in training and familiarity with its concepts and tools, acquiring expertise in PyQuest. Specific development practices may require time and investment. The vendor reliance, as PyQuest is developed and maintained by the Cisco users, are reliant on the vendors for support and updates and bug fixes. So this dependence may limit autonomy and flexibility in the system development and maintenance. These are the future trends of PyQuest advanced security measures. PyQuest is expected to incorporate enhanced security features to counter evolving cybersecurity threats. The deeper integration in automotive sector, given the growing complexity of automotive systems, the PyQuest may depend its integration in the sectors, especially in the areas like advanced driver assistance systems, the autonomous driving, and in vehicle environment. Integration and emerging technologies, the PyCoS might leverage emerging technologies like artificial intelligence and machine learning to enhance the embedded systems with advanced analytics and decision making capabilities. The streamlined development process, the PyCoS could invest in the refining development tools and workflows to streamline the design, the implementation, and certification of embedded systems. This may include enhancements in debugging tools, simulation environments, and automated testing frameworks. Diversification into new industries. While PyQuest has strong foothold in the sectors like aerospace and automotive, there may be opportunities for expansion into new industries such as smart infrastructure, energy, and defense. The PyQuest could tailor the offerings to address the unique requirements of these sectors while maintaining its commitment to safety and reliability. The continued emphasis on certification, the PICO's reputation for the certification capabilities is likely to persist. The platform may evolve to simply the certification process, further empowering developers to achieve compliance with the safety and security standards which are more efficiently used.